Okay, Assalamu alaikum.
Alaikum salam.
Okay, since we have a quiz today at the end of the class during the last 12 minutes, so I will just go and start the lecture so that we stop early. Okay. Let me just share. Last time we did, we considered functions of 2 and 3 variables, okay, and we said the main points, you have to know how to find the domain always, sometimes the range, and sometimes the graph of some functions. Okay. The next point is a short point. It is about level curves and level surfaces. So for this one, I made a recording, just to check the video or the recording in team of the office hour. Okay, team, okay. So it is a short recording, maybe 15 or 16 minutes. So just go to the office hours team and just watch the video. Okay, it is a short point. Okay, so I will start 14.2 now, section 4.5, which is now calculus of functions of 2 and 3 variables, and we start with limits and continuity of functions of 2 and 3 variables. Okay, and before we'll do first limits. So for limits, just first let me recall Math 101, just a reminder. Math 101, the limits in Math 101. Well, you have the following. You have, this is the x-axis and this is the y-axis. This is x0. This is L. And this is y equals f of x. So you have a function, y equals f of x, and the question is, what is the limit of f of x as x approaches x0? Okay. What is the limit from the graph? What is the limit from the graph? It is L. It is L. Okay, it is L. Okay. What is the intuitive meaning of limits? Okay, it means the following. As x approaches, or as x gets closer and closer to x0, but never equal x0, then the values of x gets closer and closer to L. Okay, as you approach x0 from both sides, and for example, this is x here, and this is f of x. As x approaches x0, then f of x0, this point will approach the whole, and the whole has the y equals L, okay. Or from the other direction, okay, we approach it again as x approaches x0 from the other direction. Again, the point will approach the whole, and the whole has the y coordinate L, okay. So it means basically, as x gets closer and closer to x0, the values of x gets closer and closer to L. Okay, this is the meaning of limits. Okay, the main rule in Math 101, which is the following: to find the limits, you have also limits from the right, as x approaches x0 from the right, and limits as x approaches x0 from the left. Okay. So we say the limit exists and equals L if the right hand limit equal the left hand limit, and it is equal the common value L. Okay. If the left hand limit equal the right hand limit, then the limit exists and equal the common value L. Okay. So this is the meaning, basically the intuitive meaning of limits in Math 101. Okay. In Math 201, it is really generalization. It is the same idea, but it is just a mere generalization. Okay, so Math 201, you have the following. Math 201. Okay. Now I have the following limit. Now the domain will be points as xy approaches x0, y0 of xy equals. Okay. So you have something like this. This is the space. This is x, and this is y, and this is z. Okay. Now I am approaching x0, y0. The domain of the function will be the floor. Okay. So take a point in the domain. This is x0, y0, x0, y0. The function is h, is a surface. So this is s, a surface. Okay, this is a surface. Okay, so this is z equals f of x, y. Okay, now we just, this is h, a hole here, and this is h, l. Okay, so now as you approach this point in the floor, remember your domain is the floor. Your domain is the floor. You are moving in the domain, which is the floor. Okay. So for example, if I take a point xy here, x general, and I am approaching x0, y0. Okay. This is the corresponding point of xy, of xy. Then this will approach, and hence z will approach l. Z will approach l. Okay. Z will approach l. Okay, so as xy gets closer and closer to x0, y0, f of xy will approach the value of xy will approach l, the value l will approach the value l. Okay, it is the same thing as in math 101 really. Okay, a main difference or one main difference between math 101 and math 102 is the following. In math 101, okay, you can approach a point x0 either from the right or from the left. Okay, you have two directions to approach x0, either from the right or from the left. Okay, so you have right hand limit and left hand limit. Okay, in math 101, this is, we have a different situation. I can approach this. Remember, my plane is, my floor is the domain, so I can approach x0, y0 here through different paths. I can approach it through this path, okay, or through this path, okay, or through this edge path, okay, and etc. Okay, so I can approach a point through different paths, okay, in the floor, okay. My domain is the floor, okay, or in the floor, okay. So I can reach the point x0, y0 through different paths, through infinitely many paths, okay. So what is the corresponding rule? In math 101, the limit, the two-sided limit equals L. If the limit from the right equals the limit from the left equals the common value L, okay. Here, in math 201, the limit equals L if what? If the following, okay. Limit as xy approaches x0, y0 of x, y equals through all paths, Okay. And here I have many paths. I have to check the limit along this path is L, the limit along this path is L, the limit along this path is L also, and the limit along this path is L, okay. So you have infinitely many paths. I have to know, I have to make sure know all the limits equal, okay. The value of the limit are equal, okay. So this is the definition and the rule, okay. There is a point to be considered. I will mention it, important point. I will mention it next time because I will not need it today, okay? Because I need to finish before the quiz, okay? But there is a point about math 2, about the limit in math 2, or about the limit about paths, okay? About paths. For now, just you take it as intuitive definition. There is a main point that will be that I will mention next class, okay? So there is no need to mention it. There is no need to mention it today, okay? Now this is the definition. Now, of course, the main point really, and how to compute limits, okay. And we have methods, the methods for computing methods, the methods for computing limits. We have two methods. Let me call the first one math 101 methods. And the second one, the new methods, math 201. We have two classes of methods, or two methods of math 101, methods of math 201, okay. Again, today I will just explain the methods of math 101, and I will leave the method of math 201 next class, okay. But we concentrate on math 101. And now you will see really you need to just refresh your memory, recall some of the methods of math 101, okay. Okay, what are these methods of math 101? I will illustrate them with examples directly. So pay attention, the situation is you will see really the idea, The ideas here are not new. You have seen before. You need just to recall them. Okay. Find the limit. Find the limit. If it exists. We take example 1. Limit as xy approaches 0 len 2 of e power x minus y. Okay, so we need to find this limit. Okay, we apply what we usually do in Math 101. What is the first step that you do in Math 101 to compute the limits? We substitute. Okay. And just substitute. Okay, substitute. And see what you get. Okay, so now substitute equals. Okay, and xy approaches 0 len 2, so x will go to 0 and y will go to len 2. So I replace x with 0 and y with len 2 and substitute. So we go to he x is 0 minus y len 2. Simplify. This is e power minus len 2, and this is e power len half. Properties of the len, you just bring the negative as the power of the 2. Okay, becomes 2 power minus 1 half, and this is this is half. Okay, so you have to substitute and see what you get. Here we get a value, a real number. Then the value of the limit is half. The value of the limit is half. Okay, you substitute and see what you get. Okay, second example. Okay, 2 here. Limit as xy approaches 1 and minus 1 of x cubed plus y cubed over x plus y. Okay. Again, you substitute. So x approaches 1, y approaches minus 1. So substitute x equals 1 and y equals minus 1. You get 1 minus 1 over 1 minus 1, which is 0 over 0. 0 over 0 is undefined, so it is not a real number. Undefined. Okay. Undefined. Okay. If it is undefined, what do you do in this case? If it is 0 over 0, okay. Okay, so this is usually your expected answer. Pay attention, Hannah. This is a function of 2 variables. Okay, so no, there is no L'Hopital's rule for functions of 2 variables or functions of 3 variables. Rule for function
as a common factor.
خلنا بس خلص هاي. Okay, just let me finish. Okay, so from the start it is good. No, just so don't think of L'Hopital's rule when you have functions of 2 and 3 variables. Okay, because there is no such rule. Okay, L'Hopital's rule for functions of 1 variable. Okay, واضح ولا لا؟ we remove this from the start. Okay, but we said the methods of Math 101. Remember, no, the methods of Math 101 are not restricted to L'Hopital's rule. You have to remember. Math 1, chapter 2, the methods of chapter 2. Okay, in chapter 2 there are several methods there. Okay, one of them is factoring. Well, you simplify by factoring. Okay, so if there is no L'Hopital's rule, I go to chapter 2 and I have factoring. I have x cubed plus y cubed. I can factor this. This is a sum of 2 cubes, so I simplify by factoring. You just factor. This is the numerator x plus y. This is x squared minus xy plus y squared over x plus y. Now cancel the x plus y. When you cancel the x plus y, you get x squared minus xy plus y squared. Okay. Now the limit as xy approaches 1 and minus 1. So this is what is it? You factorize, simplify, you get this. Now substitute, you get 1 plus 1 plus 1 equals 3. Okay, so this is one of the methods in chapter 2 of Math 101. Factorize and simplify. Okay. 3. What is the limit as xy approaches 2 and 2 root x plus y minus 4 over root x plus y minus 2. Again, you just simplify, substitute x equals 2 and y equals 2. When you substitute, you get 4 minus 4, which is 0, over root 4, which is 2 minus 2, 0. Okay. Again, undefined. When you substitute, you get 0 over 0, undefined. You cannot use L'Hopital's rule. I can use methods of chapter 2. What can I? Exactly. You have, whenever you have a root, you remember, usually we multiply by the conjugate. But you simplify using the conjugate. Multiply by the conjugate. Okay. So multiply by the conjugate and then simplify. This is x plus y minus 4 over root x plus y minus 2. The conjugate هيكون root x plus y plus 2 over root x plus y plus 2. Okay. Numerator will be the following. This is x plus y minus 4 root x plus y plus 2. Denominator, this denominator هيكون ايش؟ root x plus y squared minus 2 squared. Okay. And when you simplify, you get x plus y minus 4. Okay. Cancel. So always when you have 0 over 0, there is a cancellation. Okay. I cancel these two terms. You get ايش؟ root x plus y plus 2. Now the limit as xy approaches 2. You just bring it here and you write ايش؟ equal. Okay. Substitute, you get ايش؟ root 2 plus 2 plus 2 equals ايش؟ equals 4. Okay. Again, using the conjugate. Okay. Factorization or the conjugate. Okay. By just recalling the basic techniques of Math 101 and yeah, now really I am refreshing your memory here. Okay. There is nothing really new up to now. Okay. Now for limit as xy approaches 0, 0. This is x squared cosine 1 over xy. Okay. Substitute x equal to 0 and y equal to 0. You get h0 here. Cosine 1 over 0. Okay. 1 over 0 undefined. Cosine undefined. Undefined times 0 undefined. Okay. كله undefined. Okay. Undefined. Okay. So how to find the limit in this case? Okay. You cannot factorize. You cannot multiply by the conjugate because there is no root. What do you do here?
Square theorem.
Exactly. Always, if you remember in Math 101, if you have cosine and sine of a complicated function, usually we use the squeeze theorem. Okay. And just refreshing your, recalling what you already know. Yani. If I use the squeeze theorem. Okay. What is the idea of the squeeze theorem? Well, we have this complicated function here. We try to squeeze it by simpler function. Squeeze the function here by simpler function. How? We start with the cosine. So we know that cosine 1 over xy. The cosine is always between 1 and minus 1. But provided the denominator is not equal to 0. You write this condition because the denominator is 0. This is undefined, so it doesn't lie between two numbers. Okay. Now I multiply by x squared, so this implies minus x squared less than x squared cosine 1 over xy less than x squared. Okay. So I squeezed my complicated function by two simpler functions, minus x squared and x squared. Now I find the limit of the squeezers. Okay, so this is the limit of this one. Limit as xy approaches 0, 0 of minus x squared. I substitute x equal to 0, I get 0. And this one here, limit as xy approaches 0, 0 of x squared, again equal to 0. The squeezers approach the same value, 0. Okay. If they approach the same value, then the squeezed will approach the common value. Okay. This is the idea. This is the content of the squeeze theorem. So limit of x squared cosine 1 over xy as xy approaches 0, 0 equals the common value. What is the common, the limit of the squeezers? 0, 0 and 0. Just take the common value. What is h? 0. Okay. So this is h, the squeeze theorem. This is the squeeze theorem. Okay, so the main methods of Math 101 in chapter 2, factorize if possible, yani simplify your function by factorization if possible, by multiplying by the conjugate if possible, or using the squeeze theorem, Now, a fifth example, limit as xy approaches 1 and minus 1. Len 1 plus x plus y over x plus y. Okay. Pay attention to this example because there is something new here. There is something new for this example. Okay. Again, you substitute xy approaches 1 minus 1, so x approaches 1, y approaches minus 1. When you substitute 1 plus 1 minus 1, 1, then 1, 0, over 1 minus 1, 0. Which is undefined. When you substitute, you get 0 over 0, which is undefined. I have to use the methods of Math 101. Can I factorize? No. Can I multiply by the conjugate? No, because there is no h, there is no roots. Okay. Can I use the squeeze theorem? Usually the squeeze theorem is not easy to use. Okay. Yani if you have the cosine and the sine, then try the squeeze theorem. Otherwise, it is not easy. It is not easy to use. Okay, we don't have cosine and sine, so we can just ignore it. Okay. So what do we do in this case? Okay. All of the previous.
L'Hopital rule.
شو قلنا L'Hopital rule من ساعة.
Take the derivative.
Forget it.
Numerator.
This is the first observation we did. يعني the second or in the example 2 قلنا إنه إيش. There is no L'Hopital's rule in the first example. Yeah? This one here in this example, we said no L'Hopital's rule. Okay.
And we forget for L'Hopital.
Yeah. Okay. If it is a function of 2 variables or 3 variables, don't use L'Hopital's rule. There is no such rule. Okay. L'Hopital's rule for functions of 1 variable. Okay. Plus of course. Up to now, we don't know how to differentiate functions of 2 variables. صح ولا لا? We don't know how to differentiate functions of 2 variables. Okay. خلي L'Hopital's rule يعني away for a while. Okay. It is applicable for functions of 1 variable only. So now what do we do here in this case? Okay, in this example here. Okay. There is a little trick here. There is a little trick. Okay. The trick is the following. Still, I will use Math 101, but notice how. Okay. The trick is the following. Trick here. Okay. Change to Math 101. What do I mean by this? Notice the function here. The denominator is x plus y, and the numerator also contains x plus y. So I have the same quantity, x plus y in the numerator and x plus y in the denominator. The same quantity. So I will just combine these two quantities together into one new quantity. So I will say let u equals x plus y, I have the same quantity. I will combine them into one quantity. I will call it u. In this case, what will happen? Okay, notice what will happen. Okay, equals. The function becomes len 1 plus u over u. Okay. So, okay, when I change the variable, I get this one. Now, what kind of a function is this one? Okay. A function of how many variables are the new one?
One.
A function of one variable. A function of 1 variable. So when I say change to Math 101, معناته change it to a function of 1 variable. Okay. Well, this is limit now. Limit. لازم يكون limit u approaches something. You change it to u, a function of u. You have u approaches something. Approaching what? Notice I have this relation between x, y, and u. Okay. So this is the relation. So now f if xy approaches 1 minus 1, because xy هنا approaches 1 and minus 1. Okay. Then what will happen to you then? Then you will approach as 0, because u equals x plus y. هذا relation. If x equals 1, y equals minus 1, the sum will be 0. Okay. So you will approach 0. Okay. You will approach 0. Okay. Then I put you approaches 0. Okay. Now find the limit here. Find the limit. When you substitute u equal to 0, what do you get? You get h 0 over 0. Okay. Undefined. Okay. Well, how to find this now? How to find the limit in this case? Okay. L'Hopital's rule. Why you can use L'Hopital's rule here? Okay.
One variable.
Because it is a function of one variable now. Just you, a function of you. You change to a function of one variable, and then you can use L'Hopital's rule. Okay. But this is the trick here. Okay. So now by L'Hopital's rule, limit u approaches 0. What is L'Hopital's rule? It's just replace the limit by the new limit, where the numerator here, replace it by the derivative. Denominator, replace it by its derivative. What is derivative of ln 1 plus u? هتكون 1 over 1 plus u. What is derivative of u in the denominator? It is 1. So I just put 1 here. Okay. Simplify and limit as u approaches 0, 1 over 1 plus u. And this is 1 over 1 plus 0, which is h, which is 1. Okay. So the limit equals 1. Okay. So when you have in the limits a quantity, a common quantities like in x plus y, I can go into one quantity and change my function to a function of one variable. Then you feel happy because you can use L'Hopital's rule here. Okay.
What
Again?
What if there is no common value?
خلاص معناته you cannot use this technique. You have to think of something else. Okay. Okay. So this is H, how to find the limit. So to summarize, the methods of Math 101, always you start, when you compute limits, always start with the methods of Math 101. Okay. The methods of Math 101 are the following. You have using the methods of chapter 2, you have to substitute. If you get a real number, that's it. This is the value of the limit. If you get 0 over 0, then think of factorization or multiplying by the conjugate when you have roots. Okay. When you for limits that contain cosine and sine, and you have weird functions, you keep the squeeze theorem in your mind. Maybe the squeeze theorem will work. Okay. If not, the trick, the last one, the trick, make sure if there is a common quantity in the numerator and the denominator, then we can solve it by changing to a function of one variable. Then we can use L'Hopital's rule. Okay. Then we can use L'Hopital's rule. Okay. If you can change the function to a function of 2 variables or 3 variables to a function in 1 variable. Okay. When there is a common quantity in the numerator and denominator. When you change it to a function of 1 variable, I can use L'Hopital's rule. Okay. So this is H. This is the summary, or briefly, method 1. Okay. For the first method for computing limits of functions of 2 variables. Okay. Next time we consider the second method, or the methods of 201, the new methods, just restricted to Math 201. We do this inshallah next time.
دكتور في سؤال عام بس. الآن دائما ماس 101 يضبط.
Just repeat please again. Repeat your question.
دائما طرف ماس 101 تضبط.
في تقطع في صوتك، ممكن مرة ثانية بس. اوكي.
هي دائما طرف ماس 101 تضبط.
Yeah, usually this is as you noticed هنا. Usually مش ما بنقول دائما لأنه هذه methods. فالmethods are restricted to some class, some types of functions. We cannot say no, it has to work. Okay. But if I can factor, well, okay, fine. If I can multiply by conjugate, try and see what you get. If you get something similar, okay, that's it. Otherwise, maybe I have to use other things. So these are possible methods. These are possible.
The difference is just two variables in not one.
Yes, هذا الديفرنس. Okay. 2 or 3 طبعا 2 or, but in the examples I gave 2 for today, but also or limits of functions of 3 variables. You will use the same idea. Okay.
هذا دكتور أخذ درس في الميجر.
This is part of the major. Yes, next week.
هذا أخذ درس ولا في بعد شيء جديد؟
لا this one only this one 14.2 only. Okay. So inshallah we do it. We continue next class. Okay. Okay. So this is Ish. If you have no question, okay. So I will stop here. Okay. So now the quiz will start in 10 minutes. يعني at 10:40 the quiz. So if you don't have any question, you can just prepare yourself. يعني prepare yourself. Just يعني position yourself so that or turn on your camera. The usual way, the usual things. Okay. And you have to go first. You have to access Blackboard. Then from Blackboard to WebAssign. Okay.
Doctor, the quiz will be 15 minutes?
No, the quiz will be 12 minutes. It will consist of 2 simple questions, 6 minutes for each question.
Okay, thank you.
But it will start at 10:40. So just يعني position, be ready for the quiz. Just go access the quiz. يعني خليك in the ready position so that by 10:40 you start the quiz. Okay. But access is through